and happy Monday to everybody. That was a great pre-class conversation we just had with David. Just to summarize, we were talking about petroleum and methane hydrates. Petroleum does come from organic sediments, biogeneous in some texts, and how did you pronounce it before, Dave? I don't have my book in front of me.
Well, it's spelled with Biogenous. So I would not say biogeneous because it's biogenous.
That's just depending on what text you did. In our text, it says it biogenous, and that's great too. That would be a synonym. But anyway, the petroleum comes from the sea creatures as they sink, and then they're covered. And over time, from the heat and pressure, the organic portion separates out and forms an oil layer, a water layer, because oil and water doesn't mix, and a gaseous layer on top. So it's a three-layered system that's trapped in the rocks. When it's discovered, the oil driller, be it in the Gulf where they drill through the water, the rigs, or on land, it drills in, and the first thing you hit is the natural gas because it separates by density, and gas is the least dense. And then before we realized the scarcity of oil, or before it was actually valued as much as it is today, the natural gas was actually considered a waste product, and it was burned off, wasn't even harvested. Then they got to the petroleum, and then you get briny water. So, because the petroleum oil is less dense than water and kind of floats on top of it. So when you tapped your well, you would be pumping salt water. Do you know that well was tapped and you'd move on? Now, of course, the natural gas is valuable, and it's separated into its components by a process similar to fractional distillation, where you allow that gas to separate by density into its components, methane being the lightest, ethane the next lightest, butane, propane, it separates out, and then you can sell or utilize the individual components. Now, the hydrates are natural gases that are trapped at depth, and because of the cool and the pressure, they take kind of a slurry formation. If you were to bring them up and leave them exposed, they'd evaporate away as natural gas. It's just another natural resource. It's formed similarly. It comes from similar origins as the petroleum, but it would be a precipitate. It precipitates out of the seawater at cold and at depth. So we were discussing that, and then it dovetailed a little bit into climate change, which will be a recurring theme throughout this science class because the oceans moderate climate, and they have absorbed the carbon dioxide, the calcium carbonate cycle. Also, because there's methane trapped under the ice caps, as the ice caps recede, methane is going to be added to the atmosphere, and methane is a greenhouse gas. So that will contribute to the change in temperature on our planet as the ice caps recede. So that was kind of like the pre-class discussion, which was quite interesting, just to reiterate, so it's on tape so everyone gets the same information. Again, I'd like to tip my cap to David for such thoughtful conversation to get things started. We have a few items on our agenda today. The first item on the agenda I would like to share is the quiz review. If you recall, we have a quiz that is due Wednesday. I put out a review and I said that I would go over it today. So let's do it. If you would have a look, the first part of the quiz is on plate tectonics, Albert Wegener and his continental drift theory. And we're looking at a little bit, because he was a climatologist, we're going to look at what role latitude plays in climate distribution. Now remember, latitude is the distance north or south at the equator. We do know it's warmer at the equator. We do know it's colder at the poles. So an increase in latitude would cause climate zones to be progressively cooler, whether it's a positive increase toward the North Pole or a negative increase toward the South Pole. And that's because Earth's got a curved surface, and at the equator, you get more direct sunlight. And as you move up that curve, the sunlight hits at less of a, at a different angle, less of an angle. 90 degrees would be direct, and you would be getting more diffuse light as you move away from that, causing the change in climates. So that's just addressing the role of latitude. There's other factors in climate, and as we move through climatology, you know, ocean currents and the orographic effect caused by mountains. So there's a bunch of effects that cause climate, but we'll start off with the latitude as we move through the course. The two places in the world where we have continental ice sheets still is continental ice sheet exists on Greenland and Antarctica. Then remember, the Arctic Ocean is covered, but being it's an ocean, that ice is floating. One of the importances of that is the floating ice is already in the water. So sea level wouldn't rise when that melts. It will rise Greenland or Antarctica, but it won't rise for the ice cap, the northern ice cap. What will happen though is the ocean conveyor belt will be disrupted, and that will also contribute to a change in climate as we lose ice. The breakup of Pangaea, we looked at that. About 250 million years ago, all the land was together. It broke up somewhere in the neighborhood of 200 to 220 million years. The oldest ocean sediments at present are about 200 million years old. It's separated into Laurasia, Gondwana, and then further the separation of Africa and the Americas, creating the Atlantic Ocean. So the youngest parts of the ocean floor are found at the ocean ridges, while the oldest parts are found at the subduction zones. And then after subduction, it's pushed down into the mantle and melts. And that's why we don't have any ocean floor over 200 million years ago, but we have continent crust almost 4 billion years old. So the continents are a much more permanent fixture on our Earth than the ocean floor. The map given below, you see, I promised I'd give you this chart. It's very similar to the one in the PowerPoint. And you're going to be wanting to locate examples and discuss examples of convergent, divergent boundaries. The convergent ocean to ocean would be here in Japan, where you get the island arcs, or the Aleutian Trench, where you get the island arcs. The convergent continent to ocean would be here, where you get your coastal mountains, or up here where you get your coastal mountains. The divergent boundaries are all of these along the mid-ocean ridge. And then on the continent, there's a divergent boundary here, Africa, the East African Rift. And of course, the most famous transform boundary is here at the San Andreas, but you have a lot of little micro transform boundaries here on the ocean floor because of uneven spreading. So you're going to have to recognize and exemplify some of these plate boundaries. Looking at submarine canyons and ocean trenches, remember, submarine canyons form from erosion, so they're perpendicular to the coast, and they're formed by ancient rivers that eroded out valleys, and then as sea level rose, those valleys flooded, and now there's submarine canyons where deep ocean trenches form at these subduction zones And so the canyons are still on the continental shelf, so they're not that deep compared to the deep ocean. I mean, they're still relatively shallow. They're just valleys carved out by ancient rivers. Whereas the trenches are the deepest parts in the crust. So trenches are formed by subduction, and they're far, far deeper. We've been mentioning island arcs, and another term for island arc is archipelago. But we've been talking about their formation, and they form at ocean to ocean convergent subduction, that uplift of the overriding plate. If you recall, there's an underplate subducting plate, the one that slides under, and the overriding plate gets pushed up, and that is volcanic island arcs. An example of a volcanic island arc, I'll give you three right off the top of my head. You have the Aleutian Islands, the little tail of Alaska. You have Japan, which is an island arc, and the Caribbean island arc. And all those are formed by ocean to ocean subduction. Now, the Himalayan mountains is the land to land collision. It's the end of the Wilson cycle, as we recall, that suturing let's think of Pangea. The Pacific Ocean and the Tethys Ocean were the two oceans of Pangea. As Pangea split up, the Tethys Ocean was the first to be closed, and right now the remnants are found at the Mediterranean Sea. The Pacific Ocean is also closing. So oceans tend to open up and then close. And once they're closed, you would be left with a salt lake like the Mediterranean Sea will be. But that doesn't stop plate tectonics. Those plates are still being squeezed together. And when the ocean's all gone, you have what we call suturing, the end of the Wilson cycle. The Himalayan mountains right now are the end of that Wilson cycle. That's crust, continental to continental convergence. The Hawaiian Islands form as the Pacific plate is sliding over the hot spot in the Pacific Ocean. If you recall, mantle plumes are upwellings of mantle. They could occur at a plate boundary, like Iceland. They power plate tectonics. They could occur in the middle of a plate, like Hawaii, or under a continent, which is the worst case scenario, but they don't erupt that often, like Yellowstone. So this mantle upwelling or mantle plumes, that's how Hawaii formed. Charles Darwin, we discussed his voyages. His theory on coral reefs have to do with plate tectonics as well. Think of Hawaii, and as it's sliding, you have seamounts, the undersea extinct volcanoes, but they're still shallow, so coral reefs grow there. As they grow there and the island continues to sink, they form what's called an atoll. So Charles Darwin believes that coral reefs come from the subsidence of extinct volcanoes. Now, satellites, we mentioned, can map the ocean floor because sea level follows the contours of the ocean floor. And because of that, over a trench, sea level dips a little bit. Over a rise, sea level rises a little bit. It's up to 10 meters change in sea level. So that can be measured because we have very precise instruments measured from satellites. So the ocean floor has been thoroughly mapped by satellite technology. Now, the speed of sound forms what we call that SOFAR zone. And there's a minimum sound layer at the depth of 1,000. But sound travels faster through pressure. The more pressure it gets, the faster it goes. So the deeper it would go faster, below that minimum level. Temperature, it slows it down a little bit. And that's why that middle happens at the sweet spot at 1,000. So temperature and pressure. A fathom is 6 feet when we read maps. You guys did a very nice job on comparing, contrasting active and passive margins. Abyssal plains and hills is a good one. Our book calls guyots tabletops, I believe, tabletops. So if you see the term tabletop or table mount, that's also called a guyot. That is a flat top abyssal hill. Abyssal hills are extinct volcanoes as it spreads. If it's flat on the top, because of maybe erosion, because it was above the surface at one time, or just it formed that way, or that would be called a tabletop, table mount, guyot. They're all the same things. Ocean trenches are along the margins of the Pacific Ocean, because obviously the Pacific Ocean is the Ring of Fire. And then we got the types of sediments that we discussed last time. Now, the last glacial period ended, well, it ended about 15,000 years ago. 15,000 years ago it ended, and sea level abruptly rose between 15 and 10,000 years ago. Because the ice caps melted, sea level abruptly rose. So the Wisconsin glaciation period was our last full-on glacial time. So this is a summary of the quiz. What I would suggest you do in preparation for the quiz is to write all these out. I like write more than copy and paste, because there's such a thing as tactile learning. You kind of read it to yourself as you're writing, but you don't really tactile learn when you copy and paste and stick something in there. But so I'm just going to suggest you write these out. You can use the index of the book as you gone through the chapters. You can use Google and just copy a question right off in Google. You can go through the old PowerPoints and pull the information directly there. I'd like to remind you that things like biogenesis, biogenesis, different sources use different terms. I just basically use the terms I was taught when I was in college. We did not use this edition of the textbook. I'm just old and always think of the way I was taught, kind of remember it when I do my PowerPoint notes, but they're generally the same thing. So that's why a tabletop is the same as a guyot, is the same as a table mount, things along those lines. So as you go through it, don't get confused by the change of a word here and there, because various texts and various authors have the words they were taught, and they generally mean the same thing. But I would go through and answer these, and because your quiz is open notes, you would be able to have them there as a reference. Then when you're taking your quiz, answer the ones you know from your head. And that way, if you're looking something up, you don't get stuck in a time crunch. So you go through and you answer them all, you hit save just in case something goes wrong. Then you don't submit yet, you just make sure you save your answers as you go along. Then you go back and you look up the ones that you need to. If you have this completed, you have a handy dandy note card right there, and you should be able to find just about everything you're looking for right on there. So that's how I suggest you prepare for quizzes. Now, the midterm, we do have an extensive review that you're going to turn in, and you're not going to have the benefit of that reference when you're taking the midterm, but hopefully you'll study it enough so you know it by heart. So I've seen students do great things. As long as you do the work, success will be right there for you. You know, anyone who puts in the work, you know, gets decent grades. So don't worry about, I'm a good test taker, I'm a rotten test taker. You know, you do the work and you do all of our work, and everything always turns out decently. It's when you start missing assignments that grades really suffer the most. So this is a quick review of our first for Unit 2 quiz.
Professor,
Yes.
David again.
Yes,
Some of
sir.
some of us like to contemporaneously prepare for the quiz, and it would really be helpful to me, at least, for you to publish that quiz review sooner than later.
Well, I'm gonna do it at the pace that I can keep up with because I have a bunch of classes and so as part, I'll do it as soon as I can, but I'm not gonna make any promises because you know, I have other chores or other job duties.
Understood.
I'll definitely get it out before for plenty of time to study, but I can't necessarily get it out in an instant, if you know what I mean. All right. I'm having some issues with my Zoom again, believe it or not. I have to write a ticket. What do you guys, David, what do you see on your screen right now?
I just see your face.
Oh, geez, I'm sorry for that. I am going to have to log off and log back in. So we're going to have another two-part video extravaganza. Please hang in there for the couple of minutes. I will be having the tech team come check my computer, but I'm going to have to try to log back in because my screen share buttons disappeared.
But we don't have to log out and back in, do we? We just sit tight.
No. I don't think just sit tight and I'll be right back, okay?
Right.
I'll be right back, sit tight. And I have a ticket into the tech people and they're gonna come see what's wrong with my computer. So give me as long as it takes to log out and log back in.